Thanks,
Hi.
Jim. Yeah, and hello to all the attendees and fellow speakers. My talk today really is to give an introduction to the AI Lakehouse and give a little bit of history and some important takeaways when building batch real-time AI systems. Now, the this the story of the AI Lakehouse is really the story of the offline feature store. And what I mean by that is that we're seeing essentially these two different, the Lakehouse features incorporating a variety of different machine learning infrastructure services and basically AI pipelines that make it really an interesting merging of or convergence of two different areas that have been progressing over recent years. Now, in terms of for the 0.01% of people who don't know what a lakehouse is, you can think of a lakehouse as a way for an enterprise to separate the storage of its enterprise data from the processing or compute of that enterprise data. So in the very beginning, storage was done using Parquet files, and that had a number of problems in terms of updating that in a consistent way, right? So Parquet files was typically stored on some form of object storage, mainly S3, and then people introduced table formats like Delta or Iceberg or Hoodie to tackle some of the challenges of updating Parquet files over time. And with the table formats, you had the introduction of catalogs. And in terms of compute, there was a number of different query engines being introduced, lots of interesting innovation happening in this space, like SQL-based or batch-based query engines or streaming query engines like Flink. And then there's a whole set of tooling built on top of this for users to do analytics and various different type of reporting, etc. But the main takeaway from this is we've seen the separation of storage and compute in terms of data and in terms of query engines. And in terms of the recent history, what on the bottom here of this slide, what you can see in terms of the Lakehouse, Databricks introduced Delta Lake back in 2019, and we had the Iceberg spec from the Apache project. Later in 2021, we had the sort of Lakehouse architecture and then a variety of different query engines being introduced like Dremio, Trino, Presto. We've seen a lot of adoption of Iceberg, AWS Glue adding support for Iceberg. It already had support for Hoodie. And more recently, I think just recently, like last week, you had BigQuery announced support for Iceberg. So lots of very interesting things happening in the Lakehouse space. And in terms of Hopsworks, the history of Hopsworks over the last 5 years, Hopsworks was one of the first, or the first, to introduce an open source feature store. And there was always a question around how is offline data being stored. So in the beginning, Hopsworks was using Hoodie and Hive to do its offline storage. And then over time, there was an internal discussions around, should this be pluggable, right? And more recently, in 2024, we've introduced Delta support, and we're in the process of introducing Iceberg. So we see that the table formats are somewhat pluggable, right? So you should be able to plug in different table formats or plug in different query engines so that you can get whatever you need done, whatever type of work you need to get done, whether it be batch, real-time AI, LLMs, Gen AI, etc. Now, ultimately, one of the takeaways from this is that the offline feature store is essentially now a lakehouse. What I mean by that is it should be open, so you should be able to pick and choose the type of query engine that you want to use. And because it's a lakehouse, it's not virtual. Now, the follow-on question from that is, how do I go from a lake house to having an AI lake house? And what we would say is, well, it's simple, a matter of adding an online store and a vector index, and a lot of the tooling and services around that to allow you to do a variety of different to build the type of AI applications that you want to build, whether they be batch, real time, Gen AI, streamed, etc. Okay, so for Hopsworks, you really have to support different table formats, different compute engines, and be able to plug in the type of engine that you want to do for the particular problem that you have. Okay. Now an obvious question then is, well, let's talk about these AI lakehouse architectures and see the implications of how they are done. And so in the rest of the presentation, I'm going to cover two AI lakehouse architectures to sort of compare and contrast the different aspects of them and how people have been solving these problems, either batch or real-time AI problems over time. But the key point here is not all AI lakehouse architectures, not all AI lakehouse architectures are the same, particularly in terms of real time, right? And we'll get into that in a few moments. Okay, so I think everyone has seen or used TikTok at some level, but essentially TikTok has built an AI lakehouse. So TikTok's a typical user comes in, is presented with a number of videos, and over time, based on the user's history and context, a variety of different recommendations are being made to that user. Now, the key thing to note about a TikTok and ByteDance, we're talking exabyte levels of data, right? And training is being done in an ongoing basis, and your feature freshness is a key aspect to the user experience. So feature freshness is on the order of seconds, and your interaction with the AI built within TikTok is very super fast, right? Now this idea of feature freshness is key, right? So if you want to step back from this and take some abstractions from the TikTok example, what you have is you have data events coming in. So people's scrolling or swiping, and they normally come into some sort of streaming feature pipeline. I think TikTok uses Flink to write data to their AI lakehouse. And then that data gets read by an inference pipeline to present a new video or a new advertisement to the end user. But effectively, this sort of real-time AI system is doing this in the order of milliseconds or sub 1 to 2 seconds, right? And it's been architected that way because they're the use cases that TikTok want to address. But we've seen within Hopsworks, we've seen similar use cases from a variety of prospects and customers where they want to achieve this type of real-time responses in terms of feature freshness. Now, an alternative approach, let's say a non-real-time AI lakehouse architecture, would be to do ingestion, whether it be batch or streamed real-time, into your offline store. So into Delta, Hoodie, or Iceberg. And then there's some form of synchronization that goes to the online store and the vector index. So that synchronization can be done using something like CDC, change data capture. But the key point here is the writing to your offline store and then the synchronization isn't what we wouldn't consider that in Hopsworks real time. It can take on the order of minutes. So therefore, the user experience is somewhat impacted, at least in the example of TikTok, where the recent videos that you watched and liked And if you follow this architecture, they're not being incorporated into your next set of recommendations that you're seeing. Whereas TikTok have deliberately architected their AI Lakehouse so that they can get feature freshness to really, really low level so that it improves the user experience. So Hopsworks basically provides a real-time AI lakehouse. So from ingestion, whether it be real-time or batch, we can achieve feature freshness on the order of milliseconds to 1 to 2 seconds. And the way we do this is essentially by using Kafka to basically make idempotent updates to the online store, which is RonDB, and to the vector index, which is OpenSearch. And there are still in parallel to this, there are writes happening to the offline store, and they're kept in sync. Right now, the reason why idempotent updates are on this slide separates like out is that earlier version of Kafka didn't provide idempotent updates, but I think that has changed in more recent versions. Okay. Yeah, so the key point of the last couple of slides is to say that achieving real time is quite challenging, right? And the important point here is the architecture that people have settled on will directly impact the type of AI systems that you can build, right? So if you're writing to your offline store and you're not sort of you're not you're writing to your offline store, but not bypassing that and waiting for that to happen before you synchronize to your online or vector index, that'll have direct impact on how fresh your features can be, and it'll directly impact on the type of experience that you can give to your users, right? Whereas the way Hopsworks is architected, by using Kafka and a variety of other different open source tools, we're able to bypass that very slow process of writing to the store. It still happens, but we can basically speed up the writes to the online store so that you can get really, really super fresh features. Right. Now, in terms of the AI, in terms of the lakehouse, what we're seeing is the AI Lakehouse is incorporating more and more pieces of functionality, what we would consider from an MLOps platform. So you're seeing more AI pipelines being incorporated, whether like more Python support and support for a variety of different frameworks. People are starting to introduce monitoring. There's a variety of different AI infrastructure or assets like feature serving, model registry that are being incorporated or merging over time. So the Lakehouse and the MLOps platform are somewhat converging on what we would say is this AI Lakehouse. And you're seeing over time that the users of the Lakehouse or users of an AI Lakehouse want to be able to use different query engines for the task at hand. So they want to be able to use Spark because they've already built certain batch systems on Spark, or they may be using some Spark streaming. They also want to use, maybe their data is not so large and they're using DuckDB for doing really quick exploratory data analysis. They could be using Polars, they could be using Dremio. So they're basically plugging and playing the particular query engine that they want to use for the particular problem that they have. Now, in terms of how Hopsworks is architected for this AI Lakehouse, everything in green here is what Hopsworks provides, and everything else can be plugged in via. We see everything else as being something that can be plugged in, right? So we have at the very bottom, we have a variety of infrastructure services. We have a vector index, we have feature serving, model serving, etc. We have a data and model monitoring. We support a variety of different table formats, different storage, whether it be S3 or ADLS. We have a Hopsworks query service, which is essentially an AI query engine. We have very good Python support with Polars, Pandas, Gen AI, etc. And you can still use and bring the particular tools that you want to bring to the party. So if you're using Spark or BigQuery or Snowflake, we have support for that. Now, if you want to learn more about the AI Lakehouse, you can go to the this blog post that's linked here at the bottom of the page, which sort of explains in greater detail how the AI Lakehouse is done, things that you need to be aware of when building various different systems, particularly real time, uh, when you're solving your particular AI system problem. Now, last but not least, we haven't really, as Jim mentioned, we're not really focusing on LLMs, but that doesn't mean we don't provide support for LLMs. And I'd be happy to, at the end of the talk, to like on Slack or on Slack to answer any questions. But effectively, Hopsworks provides very good support for LLMs. We allow you to do a retrieval augmented generation. So, and any data that comes in that you can pull out the latest data from your offline store or for the online store to augment the user experience with the history and context that we sort of covered, we touched upon when we talked about TikTok. So that can be easily done with Hopsworks by building RAG in from the very get-go. You can do function calling, so you can pull data from your offline store into your pull offline data, pull data from your offline store to augment your generation of recommendations. And also you can do function calling to do training, right? So that's basically everything that I wanted to cover. So if there are any questions, I can take them or I can pass it back to Jim.